Now, whenever I have a binomial distribution and it's approximated using a normal random variable, then we have to remember that the binomial distribution is discrete and a normal distribution is continuous. So for a continuous random variable, probability at a single point is always 0. So it's not going to be very helpful for us at all if we cannot find probability. Alright, or whenever we want to find probability, the probability is 0. So what we have to do is this thing called the continuity correction. Now it will help us to change the single number into an interval, and because we've changed it to an interval, the probability will not be 0. Alright? So let's look at a simple example of how we can do this. Now let's say I want to find probability x equals to 2. Okay, probability x equals to 2, and then let's look at 2. Now 2 on the number line, right, is here. And any number between 1.5 and 2.5, when corrected to the nearest whole number, will always be 2. Okay? So, when we apply the continuity correction, what we are doing is, we are changing the number to x equals to 2 to x between 1.5 and 2.5. Now the way to write it is, we draw a horizontal line, and we put CC on top. Okay, CC stands for continuity correction. Now, so all we need to do to find the probability now is to use this. Okay. Now let's take a look at 2. Now in part 2, right, now let's say I want to do again a continuity correction on x less than or equals to 5. So what I'll do is, I'll think of the number line with 5 there. Alright. Now I want all numbers that are less than or equals to 5. Now that means I need to look at all numbers that are less than 5.5, because any number from 5 to 5.5 is also 5 when corrected to the nearest whole number. Okay, so when I apply continuity correction, I draw a horizontal line, put CC on top, then I write probability x less than 5.5. Alright? Now, let's take a look at probability x less than 7. Now, I look at the number 7. Where is the number 7? The number 7 is somewhere here. Okay? But I'm not interested in 7 because x less than 7 and x when it's a discrete random variable would mean I'm interested in all numbers from 0 to 6. Okay? So 6 is the number that I need, and I don't want 7. So what are numbers that when corrected to the nearest whole number will be 6? Any number that is between 5.5 and 6.5. Okay, but I'm interested in everything less than 6 and equals to 6. So when I apply my continuity correction, it will become probability x less than 6.5. Okay, remember to draw the horizontal line and put the CC on top. Okay, I hope you can see it now. It's a really simple idea. You change a number into an interval by considering all numbers that still equal to that number. Okay, the number that you want to consider. Okay, when you correct to the nearest whole number. Okay, now we look at more examples. Now let's say I'm interested in probability x bigger than or equals to 9. Then I ask myself, what are the numbers that I want to consider here? I want to consider 9, 10, 11, and so on. Okay, so I will look for the number 9. Okay, the number 9 on the number line is here. And then what are the numbers that when corrected to the nearest whole number will still be 9? It will be every number from 8.5 to 9.5. But I'm interested in all numbers bigger than or equals to 9. So I must include 8.5 onwards. Okay, so I will have probability x bigger than or equal to, if you want to insert the equal sign, 8.5, and then remember to again to put the arrow and the CC. Okay, we look at the next one. Okay, probability x bigger than 6. Now bigger than 6, again, first question I have to ask myself is, what are the numbers that I need? I need 7, 8, 9, and so on. Okay, so the very first number that I need is 7. Now, what are numbers that when corrected to the nearest whole number will be 7? It will be numbers from 6.5 onwards. Okay, 6.5 or rather to 7.5. Okay, so I will be looking for numbers bigger than 6.5 or equals to 6.5. Okay, more examples. I'm looking for now probability of x between 3 and 4, including 3 and 4. So again, I'll do this. I'll write down what are the numbers that I need. Okay, I need 3 and I need 4. So I look at the number 3 first. Now the number 3 is here. Numbers that when corrected to the nearest whole number is 3 will be everything from 2.5 onwards to 3.5. Okay, 2.5 to 3.5. Then what about the number 4? When corrected to the nearest whole number, numbers that are still going to be 4, or rather will be 4, will be 3.5 to 4.5. So that means I have to include everything from 2.5 to 4.5. So that's how I get this. Okay? Now it doesn't really matter whether you want to put an equal sign here or not. Okay, because for a continuous random variable, the probability with the equal sign is still the same. Now lastly, we look at probability x between 1 and 8. Okay, 1 and 8. And then I want to find the continuity corrected version of this probability. So I want to have numbers from 2, 3, all the way to 7. Okay, so I will look at the 2 and numbers. For 2, I have to include all numbers from 1.5 onwards. Okay, 1.5 onwards. Then for 7, I have to include every number from 7.5 down to 7. So the probability that I will need is from 1.5 to 7.5. Okay, done. Now there is one last one on the next page. I think you can try this out on your own. Okay, see whether you can get the answers here and here. Okay.